Ponganadu College of Engineering and Technology, Department of Electrical and Electronics Engineering, subject code 24EE302, subject name Electron Devices and Circuits. Unit 2 BJT and its biasing. Classification of transistor, two types of transistor, UJT and BJT. UJT is a device which conduction due to only majority charge carriers. PJ that means FET is a another classification, junction field effect transistor, metal oxide semiconductor, field effect transistor, metal semiconductor and bipolar junction transistor. The BJT is classified into two types, NPN transistor and PNP transistors. Classification, transistor, BJT and FET. So these two devices again classified in two types, NPN transistor, PNP transistor, JFET, MOSFET and MESFET. JFET is N-channel JFET, P-channel JFET. MOSFET is two types, enhancement and depletion MOSFET. Both MOSFET classified in two categories, N-channel MOSFET and P-channel MOSFET, enhancement MOSFET, depletion MOSFETs. The bipolar BJT is a three-terminal device, namely base, emitter, collector. Emitter is heavily doped, base is lightly doped, and then collector is a intermediate doping levels. This symbol base, emitter, collector, base, emitter, collector. This is a PNP, the arrow mark indicating for emitter to base terminal, that is called a PNP. Here NPN transistor, the arrow mark indicating for base to emitter terminal. It's a difference for direction of current flow through the given circuits. So that is the PNP transistor and NPN transistor. Next, the modes of operation. If transistor operates as an amplifier, it biased with the external voltage. Depends on external bias voltage polarity. Transistor works on any one of the three regions. Modes of operation: active region, saturation region, cutoff region. Based on this region, it will be working for different categories of forward bias and reverse bias. Transistor operation: emitter based junction as forward bias and collector based junction as reverse bias. So the emitter current flow through the collector region. It's a NPN region. NPN transistor working operation. So the collector current as minority carrier and majority charge carrier. Emitter to base junction as forward bias and collector to base junction as reverse bias. Holes in P region, it flows in N region to P region, that means the base terminal. Base is a lightly doping, so that small holes only recombine to electrons and the remaining holes current flow to P region. So current conduction takes place only by holes. Types of configuration. So here common base configuration, common collector configuration, common emitter configuration. The common terminal, it will be acting as both input terminal and output terminal. Common base configurations. The input is applied to emitter and base terminal. The output is collected for collector terminal and base terminal. This is a structure of common base configuration, NPN transistor. This is the structure of common base configuration, PNP transistor. Current amplification factor alpha. Alpha is equal to IC divided by IE. Collector current is equal to IC is equal to alpha IE plus CB0, that means leakage current. is a common base characteristics. Input characteristics we have to draw using x-axis base to emitter voltage, y-axis emitter current in milliamps. Next we have to find dynamic input resistance. Ri is equal to del VEB divided by del IE. Here output characteristics. The output characteristics: saturation region, active region, and then cutoff region. So next, transistor parameters. Input impedance, the value 20 ohm to 50 ohm. Output admittance 0.1 micro ohm to 10 micro ohm. Forward current gain 0.9 to 1.0. Reverse voltage gain, the value is 10 power minus 5 to 10 power minus 4. Next, a common emitter configuration. The input is applied as base to emitter and output is collecting for collector to emitter. E is a common for both input and output, that is emitter terminal. This is a basic structure diagram. This is a symbolic diagram. It is flow through the current flow direction, indicating for this arrow mark. Base current amplification factor beta, the ratio of change in output current to change in input current. The common emitter characteristics, input characteristics. Next one, output characteristics: active region, cutoff region, and saturation region. Next, common collector configuration. The input applied as base to collector and output taken emitter to collector region. C is common for both the input and the output. So the basic structure is PNP transistor for collector configuration and NPN transistor for collector configurations. The common collector characteristics for input characteristics: drawing in base to collector voltage in x-axis and then emitter current in y-axis. Output characteristics: emitter to collector voltage and emitter current. Next one, comparison of configuration. So we have to comparing for this following properties: input resistance, output resistance, current gain, voltage gain, phase shift, and application. The application wise, common base configuration is high frequency circuit, common emitter is audio frequency circuit, common collector is impedance matching circuits. Next one, two-port devices and hybrid models. So the models of parameter H11, H12, H21 and H22. Methods of transistor biasing. The following methods are used: fixed bias or base resistor method, fixed bias with emitter resistor, collector to base bias or biasing with feedback resistor, collector to emitter feedback bias, voltage divider bias or self bias. So these are all the transistor biasing circuits. So here the circuit diagram is fixed current bias or fixed resistor bias. So advantages. So it is very simple bias circuit as only for base resistance is needed. The biasing condition can be easily set and the calculation are simple. Disadvantages. These methods provide a poor stabilization. Stability factor is very high. Fixed bias with the emitter resistor, emitter stabilized bias circuit. Collector to base bias circuit. And then advantage and disadvantages. Next one, BJT as an amplifier. So the transistor acts as an amplifier by raising the strength of a weak signal. The DC bias voltage applied to the emitter base junction make it remains in forward bias condition. This forward bias is maintained regardless of the polarity of the signal. So these are all the things we have to discussing in BJT as an amplifier. The small signal analysis of common emitter amplifier, we have two various types. Common emitter amplifier with fixed bias. Common emitter amplifier with unbypassed emitter resistor. Common emitter amplifier with voltage divider bias. Common emitter amplifier with collector to base bias. So these are all the common emitter amplifier with fixed bias. And then circuit reduces the equivalent circuit. We have to find out the sum of the parameters: input impedance, output impedance, voltage gain, current gain. We have to derive for these given circuits. Thank you.